In this recording, we're going to look at writing equations of sinusoids, sine or cosine graphs, basically. Once you get your heading on there, I'd like you to play the recording. As you saw in the gizmo the other day, these are the parameters that we can use to transform basic sinusoids, sine or cosine graphs. So we've got A, which affects the height of the wave, the amplitude; B, which affects the period and the frequency of the graph; H, which shifts it left or right; K, which shifts it vertically, up or down. Okay. In addition to that, we need to know the four basic parent functions. Okay. So let's put all this in your notes. These are our parent graphs. Okay. You got y equals sine of x, which starts out at 0 and increases after that. Y equals negative sine of x, starts at 0 but is reflected, it decreases. We've got a basic cosine graph, which starts at a maximum and decreases. And y equals negative cosine x, which starts as a minimum and then increases. Okay, I want you to put all those four functions in your notes and then take some color, if you can find some color, or at least make a big blob right where I've got those purple dots. That indicates that's the key point to recognize the start of one of those parent graphs. Okay. Now let's go back to our gizmo here, and I'm going to name this same graph using either a cosine, a negative cosine, or a negative sine. Okay. Let's start out with negative sine. So as you saw before, we can put in a -1 here. Now clearly that does not anymore look like the sine graph. What I want you to do is find that point where the purple dot was. And hopefully you can see that that's the spot right here where the purple dot should be, where the sine is on the 0 and it's increasing. So what I need to do is get that point over to the left pi units. And hopefully you saw in your gizmo the other day, the way I move something to the left is I need here to be x plus pi. That'll move it pi to the left, okay? So this is moving it to the left pi units. And doesn't that look like a sine wave? Exactly. So this is y equals negative sine of x plus pi. Cool. So let's set that back. Put this back to 0. And we'll put this back to 1. Great. Now let's make it a cosine graph. Okay, this does not look like a sine graph, but I want you to find that place and hopefully look for it. Make a little point to the screen where you think the sine graph is starting, where that purple dot would be. Okay? Hopefully you identified that spot right there. That's where the graph's on the x-axis, it's at a 0, and it's increasing. Okay, so I want this graph shifting to the left 3 pi over 2. Others of you might have said, wait a second, I was looking at this spot over here, which doing the same thing. I would shift it right pi over 2. Either one will work. Turns out there's an infinite number of right answers, which is pretty cool. Well, this one's closer. Let's use this one. So this one I want to shift to the right pi over 2 units. Okay, going back up here, shifting to the right means subtracting. Okay, so I'm going pi over 2, and doesn't that take me right to make a normal sine wave? Last one. I'm going to make this back to 0. I'll make this a negative cosine. Okay, there's our negative cosine, starts at a minimum, increases. Okay, I want you to point to the spot on your screen where you see a sine wave starting out. Hopefully you point to that spot right there. That's where our sine's on the 0, increasing. Okay, so I want this guy moving left pi over 2 units. We go back and we think, what's going to make me go left? It's got to be the backwards of what I would normally think. I'm going to go actually plus to make it move left. Okay, so I'm moving it left by adding pi over 2 units. So we just showed 4 different ways to make this same graph. And that's the cool thing about these sinusoids. They're all interrelated. Right? Let's go back and make our notes. Okay. So this is our basic sine wave. I want you to put sketch of the basic sine wave in your notes. from 0 to 2 pi, and then I want you to list the 4 different ways. Again, these are just 4 of the many infinite ways we could do it. Okay? Once you've done that, I want you to write this note at the bottom. Okay? Note what we did here. We never touched the b value, because that's going to really change the graph. And we never touched the k value, because that's going to shift it up and down. The only thing we touched, I'll set this back to 0. I'm going to set the b back to 1. Okay. The only thing we touched was we negated the a value, and then we manipulated the h value. Okay? So, I'd like you to write this in your note, and then play the recording when you're ready. The only changes we can make and maintain the same graph with a different parent function are to possibly negate the a value and or change the h value. Okay? Cool. So using your companion sheet, you have little graphs. I've got this graph number 11, and I'm going to name it using a sine, and I'm going to name it using a cosine graph. Okay? Okay, so if I'm using a sine graph, first thing I'm going to do is take my purple dot and find out where I think that sine graph is starting out. Right, point to the screen where you think the sine graph is starting. Hopefully you hit that spot right there. Great. Next thing I'm going to do is identify all the characteristics of the graph that I know. Let me get a decent colored pen here. Let's go with red. Okay. What's the amplitude of the graph? Okay. Amplitude is the graph is the height of the wave above the nodal line. So that's just a 1. If you remember, amplitude is the absolute value of A, because again, I'm trying to relate it back up here to the A, B, H, and K. Frequency. Remember, frequency is how many. What's the frequency of the trips you made to the bathroom today? Something like that. So frequency is how many waves we made within a 2 pi interval. Well, I don't totally see 2 pi, but I get a sense that it's probably going to complete 2 full waves, because it definitely completes 1 wave within pi. Logically, it would complete 2 waves within 2 pi. So our frequency is 2. Period. Again, period is how long. So, how long before it completes a cycle? Well, it goes through a full cycle by pi. Period's pi. And I don't see any vertical shift. The nodal line is right there on the x-axis. Cool. So, if we're going to name this in terms of a sine graph, it's going to be a shift. Okay, so if I'm using a sine graph, I'll say for positive sine, shift. Well, I got to figure out where that is. It looks like it's halfway between pi over 2 and 0, so I'm going to call that pi over 4. Okay, so it's going to be shifted pi over 4 units. I want to shift it. It's shifted to the right from where it should be. Okay, normal sine. Okay, so it's shifted pi over 4 to the right from where normal sine is. So I need to take that into account. So I'm going to write out this function. I'm going to say y equals. Now keep in mind, absolute value of a equals 1. That means a could have been negative 1 or positive 1. I want it to be positive sine. Let's make it a positive 1. You don't have to write the 1. 1 sine. Okay, now I go up here. I need the b value. Okay, frequency equals the b value. So I'll put a 2. Then an x. Now I need the shift. Okay, I want to shift right. Remember, shifts right, we subtract pi over 4. And if I had any vertical shift, I would put that on the end here. We don't have any, so we're done. Let's grab a different color for the cosine graph. Okay, so if I'm doing a cosine graph, well, I think this looks most like a negative cosine. It's already on the y-axis and it's reflected, so I don't have any shift. So let's say for a negative cosine, No shift involved. Alright, so we said it's going to be the y equals, I have my choice, positive or negative 1. It's got to be a negative 1. Cosine. Now, remember the b can't change. It didn't get stretched in the vertical or horizontal direction. So 2x, and there was no shift to the right or left. So there's our function right there. Alright? If you have a graphing calculator, I would encourage you to put that into your y equals, and then I would like you to put that into your y equals and show that they both make this graph that you see above. Alright? Let's look at this example. Alright? This one's slightly more complicated. This one's got a bit going on. Alright? I'd like you to fill out all the characteristics you have here and then play the recording when you've got them. Okay, so hopefully you figured out that the amplitude is 3 units above the nodal line, so we're going to set that equal to the absolute value of A. The frequency is half. Now the way to think about that one is it goes between pi over 4 at a maximum, 9 pi over 4 as a minimum. That's a difference of 8 pi over 4, which is really 2 pi. So within a 2 pi interval, it's completed half a wave. That means it's going to take a 4 pi interval to complete a full cycle. The vertical shift is 0. Now, if we're looking at this as a negative sine wave, we're looking at this as our starting point right here at 5 pi over 4. So that would be shifted 5 pi over 4 units to the right. So, if it's a negative sine, I put in a negative A, which is 3, or in other words, the A value is negative 3. Sine, I've got my B value, and then x minus, because I'm going to the right, 5 pi over 4. For cosine, positive cosine would start right up here, right? That's our purple dot. It's pi over 4 to the right. It's a positive 3, and everything else stays the same. Last example. Okay, I want you to look at example 13. I want you to fill out everything you can, amplitude, frequency, period, and vertical shift. And then play the recording. Okay, hopefully you filled out that information. Now I want you to go one step further and identify a sine graph and a cosine graph. And if you have your graphing calculator, I want you to check and play the recording. Okay, so for this one, amplitude is 1, frequency is 2. Completes 2, there's 1 full cycle, 2 full cycles within a 2 pi interval. The period is pi, how long it takes to complete 1 cycle. No shift at all in the vertical direction. Okay? If I'm looking at a negative sine function, that would be my purple dot right here. No shift at all. So I put a negative in front of sine, negative 1 if you like, sine, and then 2 being the b value, x. Finally, for a cosine, this should say shift, it says shift, sorry. For cosine, the maximum is here. That's where cosine normally starts. It's 3 pi over 4. It's exactly between pi over 2 and pi, which would be 3/4 pi, to the right. So, it's a positive cosine, 2 being the b value, x minus, because we're shifting to the right, 3 pi over 4. So if you've gotten this far, you've got a pretty solid understanding, and now it's pretty much your turn to do a little comprehension check. Okay? So this is your assignment, is to do this check for understanding. This is the last graph on your half sheet, your quarter sheet. I want you to write this graph in terms of a sine and a cosine. Start the same way, fill out your characteristics of the graph, and then we'll go over this one in class. Thanks for watching.